Have you ever seen the movie The Martian? It's this incredible story about an astronaut, Mark Watney, who gets left for dead on Mars and has to use science to survive against impossible odds. Well, today, we're going to dig into the science behind that amazing story and figure out what's real and what's just a little bit of Hollywood magic. So that brings us to the big question, which comes from the most famous line in the movie. If you were stranded all alone on Mars, could you really science the shit out of it to survive? To answer that, we've got to start right where the movie does, with the disaster that leaves him there in the first place. All right, so picture this. A huge storm hits, the mission has to make an emergency takeoff, and Mark Watney gets left behind, presumed dead. He wakes up and he's completely, utterly alone on a planet where basically everything, from the air to the soil, is trying to kill him. We are talking about the ultimate survival nightmare. And that's problem number one, right out of the gate, the environment. This isn't like being stranded on a desert island. On Mars, just the simple act of taking a breath is a life-or-death situation every single second. I mean, just look at the air. Here on Earth, we're breathing this great mix of about 21% oxygen, but on Mars, forget it. The atmosphere is almost pure carbon dioxide. You couldn't take a single breath. And it's not just what's in the air, it's that there's barely any air at all. The pressure on Mars is less than 1% of what we experience here on Earth. To give you some perspective, standing on Mars would feel like being 32 kilometers up in our sky. That's more than twice as high as a passenger jet flies. Which, of course, brings us back to that killer storm in the opening scene. You know, the one with winds so strong they're knocking over spacecraft. If the atmosphere is that thin, could a storm really have that kind of power? Well, the author of the book, Andy Weir, pretty much answered that one himself. See, Mars does get these massive, planet-sized dust storms that can rage for months. But because the air is so thin, the wind just doesn't have any real force behind it. Weir openly admitted he bent the rules of physics here because, hey, he needed a dramatic way to kick off the story. Okay, so he makes it through the storm, but now he has a new problem. How is he going to eat for like the next few years? There's no DoorDash on Mars. He has to become the very first Martian farmer. And his plan is both brilliant and, let's be honest, kind of gross. He uses the Martian soil, he figures out this clever chemistry to make water from leftover rocket fuel, and then, he uses the vacuum-sealed poop from his crewmates as fertilizer, all to grow some humble potatoes. Now, what's so cool about this is how scientifically plausible it is. NASA is already doing this. They have a system called Veggie on the International Space Station where they've grown things like lettuce. And get this, experiments with simulated Martian soil show that it can be super rich in nutrients, maybe even more than some Earth soil because there are no rivers to wash them away. The real challenge wouldn't be the dirt itself, but getting the right kind of Earth bacteria in there that plants need to grow. So, Watney has figured out air and food. But he's still got to get home. And that leads to the movie's huge climax, this incredibly risky rescue mission that pushes physics right to the very edge. And the key to the whole rescue plan is a gravity assist slingshot. Now, this is 100% real science. NASA uses this trick all the time. It's how the Apollo 13 crew managed to swing around the moon to get back home, and it's how we send probes flying out to Jupiter and beyond. It is a fundamental part of space travel. But here's another one of those little moments where Hollywood just couldn't resist adding some extra drama. In the film, this totally standard maneuver is presented as a brilliant eureka moment by a junior scientist. In reality, any mission planner at NASA would have thought of that on day one. It wouldn't be a last-ditch effort. It would have been the first plan on the whiteboard. So, after looking at the storms, the farming, and the orbital mechanics, what's the final verdict? How does the science in The Martian really stack up? Let's break it down with a little report card. Okay, so the storms? Definitely exaggerated for the sake of drama. Growing potatoes? Surprisingly plausible and something we're already working on. The gravity? Spot on. They perfectly captured what it would feel like to move around in just 38% of Earth's gravity. But the one really big thing the movie kind of sidesteps is radiation. Mars has a super thin atmosphere and no magnetic field to protect it, so any astronaut would get hit with dangerous levels of radiation. That's a huge problem for a real mission that the movie mostly ignores. So, why does a movie like this even matter? Well, it's way more than just entertainment. There's this really powerful relationship between inspiring science fiction and the public support that's needed to create real science fact. You know, back in the Apollo era, when everyone was captivated by the space race, NASA's budget was over 5% of the entire U.S. federal budget. For the last 40 years, it's been less than 1%. Movies like The Martian are so important because they get people excited about space again. They inspire a whole new generation and help build the political will to fund the next giant leap for mankind. And that brings us to one last big idea to chew on. Mark Watney used science to terraform his tiny little habitat so he could survive. It really makes you wonder, if one person can do that on a small scale, what could all of humanity do on a planetary scale? Could we one day be the future Martians? Now that's something to think about.